Have you ever noticed how every electric car advertisement talks about range, acceleration, or futuristic screens? Yet almost nobody talks about the one component doing all the actual work, hidden beneath the floor, spinning silently thousands of times every minute. Is a machine so important that changing it could reshape the entire future of transportation? And according to many engineers, that is exactly what Tesla has been doing. Not with a flashy announcement, not with a dramatic product launch, but with a quiet shift that could determine who wins the next phase of the electric vehicle race. For years, the competition seemed simple. Build a bigger battery. Add more range. Make the car faster. Every manufacturer chased the same goals. The headlines focused on who could go farther on a charge and who could reach 60 miles per hour the fastest. It looked like the future would be decided by batteries alone. But while the rest of the industry was staring at the battery pack, Tesla was looking somewhere else. Somewhere most people never thought to look. And that raises a strange question. Why would one of the world's most valuable car companies spend years redesigning a part that most customers never even see? The answer begins long before Tesla became a household name. There was a time when electric vehicles were considered a joke. Most people saw them as slow, impractical machines that would never compete with gasoline cars. The roads belonged to combustion engines. The infrastructure was built around fuel stations, and nearly every major automaker believed electric transportation was still decades away from becoming mainstream. Then, Tesla entered the picture at first. Few people took the company seriously. Many assumed it would become another failed startup chasing an impossible dream. After all, history was full of companies that tried and failed to make electric vehicles popular. But Tesla wasn't trying to make a slightly better car. It was trying to challenge an entire industry. The company's biggest weapon wasn't the battery. Everyone talked about it was something much older, more than a century before Tesla vehicles appeared on highways. An inventor named Nikola Tesla imagined a world powered by electricity. At a time when steam and combustion dominated technology, he developed ideas that seemed almost impossible. Among them was an electric motor design that could produce motion quietly, efficiently, and without burning fuel. Most people remember his name. Few remember what made his ideas so powerful. But Tesla Motors did. When the company built its first serious production vehicle, it relied on principles connected to those early concepts. The result was the Roadster. And the moment people drove it, something unexpected happened. The stereotype of electric cars started breaking apart. Drivers pressed the accelerator and felt immediate acceleration. No engine roar. No gear shifts. No delay. Just instant movement. For many people, it was their first glimpse of what electric transportation could become. Hidden behind that success was a problem almost nobody outside engineering. Circles noticed the motor that made the Roadster exciting wasn't perfect. As performance increased, so did the demands placed on the system. More power meant more heat. More heat required more cooling. Higher speeds reduced efficiency, and every compromise created new engineering. Challenges. The Roadster proved electric vehicles could work. But proving something works and making it work for millions of people are very different challenges. Tesla knew that if electric vehicles were going to replace traditional cars, the company needed something better. And this is where the story starts to get interesting. Most companies would have focused entirely on batteries. Bigger batteries solve many problems. They increase range and reduce consumer anxiety. But bigger batteries also increase weight, cost, and complexity. Tesla looked at the equation differently. What if the solution wasn't storing more energy? What if it was wasting less of it? That question led engineers toward one of the most important changes in the company's history. When the Model 3 arrived, most people saw an affordable electric sedan. What they didn't see was the technology hidden inside it. Tesla had introduced a fundamentally different motor strategy. The goal wasn't just more power. The goal was smarter power. The new system delivered impressive performance while using energy more efficiently. It generated less waste. It improved range. It reduced strain on other components. To drivers, the car simply felt smoother. To engineers, it represented something much bigger. The motor was no longer acting like a simple machine. It was becoming an intelligent system. Software constantly adjusted how power was delivered. Sensors monitored operating conditions in real time. The vehicle adapted itself depending on speed, driving conditions, and efficiency requirements. But this breakthrough came with a cost. A material buried deep inside the motor suddenly became one of the most important resources in the entire electric vehicle industry. Its name was neodymium. Most consumers had never heard of it, yet without it, many modern electric motors would be far less efficient. Neodymium magnets are incredibly powerful for their size. They allow motors to become smaller, lighter, and more effective. For companies chasing maximum performance, they seemed almost perfect. At first, this looked like a major advantage. Then, reality started creating complications. The material wasn't abundant. Mining, it carried environmental consequences. Processing, it required significant resources. And perhaps most importantly, global supply chains became concentrated in only a few regions. Suddenly, a new risk appeared. What happens if the future of transportation depends on materials that become expensive, difficult to obtain, or politically sensitive? The question was bigger than Tesla. It affected the entire electric vehicle industry. Every company planning to build millions of vehicles faced the same challenge. Scaling production wasn't just about factories anymore. It was about resources, and that realization forced Tesla into another critical decision. Should the company continue relying heavily on rare earth materials? Or should it try something far more difficult? Finding a different path? This wasn't the kind of challenge that creates dramatic headlines. Nobody sees a motor redesign the way they see a new car launch. But behind the scenes, engineers started exploring alternatives. One possibility seemed almost too simple. Ceramic magnets. The idea sounded strange. Compared to rare earth magnets, ceramic magnets were weaker. They lacked the raw magnetic strength engineers had relied on for years. On paper, choosing them looked like a step backward. Yet Tesla wasn't looking at raw strength alone. It was looking at the entire system. If software could become smarter, if motor architecture could become more advanced, if efficiency could be improved through design, rather than brute force, then maybe weaker. Materials didn't have to mean weaker performance, and that changed everything. Instead of asking how to build the strongest motor possible, Tesla began asking how to build the smartest motor possible. The distinction sounds small. Its consequences could be enormous, because the future Tesla imagines isn't measured in thousands of vehicles, it's measured in millions, potentially tens of millions. At that scale, every material decision matters. Every manufacturing choice matters. Every dependency matters. A motor that performs slightly better but requires difficult-to-source resources may not be the best long-term solution. A motor that balances performance, cost, sustainability, and scalability might be far more valuable, and suddenly, the story isn't really about motors anymore. It's about how innovation actually works. Most people imagine breakthroughs arriving as dramatic inventions that change everything overnight. But history often tells a different story. Sometimes the biggest revolutions happen quietly, not through entirely new ideas, but through improving old ones until they become impossible to ignore. That's what makes this story so fascinating. Nikola Tesla imagined electric motion more than a century ago. Modern engineers inherited that vision. Then they spent years refining it, adapting it, and solving problems nobody could see from the outside. The result isn't just a better motor. It's a completely different way of thinking about the future, because maybe the companies that dominate tomorrow won't be the ones with the biggest batteries or the fastest cars. Maybe they'll be the ones that learn how to do more with less. And if that's true, then the most important battle in the electric vehicle industry may not be happening on roads, in showrooms, or even inside battery factories. It may be happening inside a silent machine hidden beneath the floor of a car, a machine almost nobody notices, yet one that could quietly decide the future of transportation itself. And if an overlooked motor can reshape an entire industry, it makes you wonder what other technologies are sitting in plain sight right now, waiting for someone to realize their true importance. The deeper Tesla looked into the problem, the more it realized something uncomfortable. The electric vehicle revolution wasn't facing a battery problem. at least not the kind most people believed. Batteries were improving every year, charging networks were expanding, manufacturing costs were slowly falling. But another challenge was quietly growing in the background. Resources imagine a future where electric vehicles don't number in the millions, but in the hundreds of millions. Every major nation wants them. Every automaker needs them. Every city plans around them. Suddenly, materials that seem abundant today become strategic assets tomorrow. And that's when supply chains stop being a business issue and start becoming a national issue. Tesla understood this earlier than many people realized. A motor isn't just a collection of wires and magnets. It's a collection of dependencies. Every material has to be mined, refined, transported, manufactured, and assembled. If any part of that chain breaks, production slows down. The company had already witnessed how fragile supply chains could become. A factory can produce thousands of vehicles per day, but if one critical component is missing, production lines stop, entire schedules collapse. Investors panic, customers wait, and competitors gain ground. That reality pushed Tesla toward a philosophy that would eventually influence almost everything it builds. Control as much of the system as possible. Most people recognize this strategy through Tesla's batteries, charging network, or software updates. But the same thinking was happening inside the motor program. The fewer external dependencies Tesla had, the more freedom it gained. The more freedom it gained, the faster it could scale. And scaling was becoming the ultimate objective, because Elon Musk wasn't talking about selling a few million premium vehicles anymore. He was talking about transforming transportation itself. That kind of goal requires thinking differently, a lot differently for decades. The automotive industry followed a familiar pattern: build a vehicle, sell the vehicle, service the vehicle. Tesla was beginning to imagine something larger. Vehicles connected through software, vehicles updated remotely, vehicles capable of operating autonomously, vehicles that could potentially function as part of enormous transportation networks. Whether those ambitions fully arrive or not, they reveal something important. Tesla isn't designing technology for today's market. It's designing technology for a market it believes will exist years from now and when you design for the future. Today's solutions can suddenly look temporary. A magnet that seems perfect today may become a limitation tomorrow. A manufacturing process that works today may become impossible at larger scales. An engineering decision that appears smart now may become expensive later. This forces a difficult question. How do you build products for a future that hasn't arrived yet? The answer often involves making decisions that seem strange in the present. And Tesla has made plenty of those. Many of the company's most important innovations looked unnecessary when they first appeared. Its direct-to-consumer sales model was questioned. Its charging network was questioned. Its software-first approach was questioned. Even electric vehicles themselves were questioned. Yet over time, many of those decisions started making more sense. Not because they were perfect, but because they were designed around a future vision rather than current expectations. The motor story follows that same pattern. To the average driver, a motor is invisible. As long as the car accelerates, most people never think about it. But from Tesla's perspective, the motor sits at the center of a much larger puzzle: cost, efficiency, manufacturing, resources, sustainability, scalability. Every one of those challenges intersects inside that single component. And that's why the company's recent motor developments matter far beyond engineering circles. They reveal where Tesla believes the next battle will be fought, not necessarily through faster cars, not necessarily through bigger batteries, but through smarter systems, systems that waste less, systems that depend on fewer scarce materials, systems that can be manufactured at enormous scale, and perhaps most importantly, systems that become better through intelligence rather than raw resources. That last idea may be the most significant of all. For most of industrial history, progress came from using more fuel, more power, more materials. The modern technology era increasingly follows a different rule. Progress comes from doing more with less. Smaller computers outperform older supercomputers. Tiny sensors replace large mechanical systems. Software solves problems that once required hardware. Tesla's motor evolution fits perfectly into that trend. The company isn't simply trying to build stronger machines, it's trying to build smarter ones, machines that compensate for physical limitations. Through engineering, machines that maximize every watt of energy, machines that extract more performance from fewer resources. And if that strategy succeeds, the implications extend far beyond automobiles, because transportation is only one. Industry facing resource constraints. Energy systems face them, manufacturing faces them, electronics face them virtually. Every major technological challenge of the next century involves some version of the same question. How do we continue growing without endlessly increasing consumption? That's a much harder problem than building a fast car, and yet it may determine which technologies survive. Looking back, that's what makes Nikola Tesla's original vision feel surprisingly modern more than 100 years ago. He imagined a cleaner, more efficient relationship between humanity and energy. The tools have changed, the materials have changed, the software would be completely unrecognizable to him. But the core idea remains remarkably similar. Use intelligence to accomplish what brute force cannot. That philosophy quietly connects the earliest electric motors to today's most advanced vehicles. And maybe that's why this story isn't really about Elon Musk or Tesla, or even electric cars. It's about a pattern that appears throughout history. The biggest changes often begin in places nobody is paying attention to. People focus on the visible product, the visible success, the visible headline. Meanwhile, the real transformation happens underneath, inside a component, inside a process, inside a process, inside an idea that seems too technical or too boring to matter, until suddenly it matters more than anyone expected. And years later, everyone looks back and realizes the future didn't change because of the thing they were watching. It changed because of the thing they weren't watching at all, which leaves one final thought. If the next revolution in transportation is being shaped by something as overlooked as a motor, then perhaps the technologies that will define the next 20 years are already here, quietly improving, hidden in plain sight, waiting for the moment when the rest of the world finally notices. And perhaps that's the most surprising part of this entire story. The closer you examine Tesla's journey, the less it resembles a traditional car company story. Most automotive legends are built around engines, horsepower, top speed racing. Victories, the loudest machine usually gets the most attention. Tesla went in the opposite direction. Its greatest achievements often happen in silence. No roaring exhaust, no dramatic engine noise, no visible mechanical spectacle, just algorithms making thousands of calculations every second, motors converting electricity into motion, software deciding how efficiently every component should operate. It's almost invisible, and that's exactly why many people underestimate it. Human beings naturally focus on what they can see. A giant battery factory is easy to understand. A futuristic vehicle design is easy to notice. A new touchscreen interface grabs attention immediately. A redesigned motor hidden beneath the vehicle. Most people never think about it, yet hidden technologies have changed the world. Before the internet wasn't built on flashy websites, it was built on infrastructure data, sensors, protocols, fiber, optic cables. The smartphone revolution wasn't created by screens alone. It depended on processors, sensors, and battery technologies that most users never understood. The same pattern may be unfolding in transportation. The visible products capture attention. The invisible systems determine who wins, and Tesla seems to understand that distinction better than most. That's why the company often appears willing to invest years solving problems customers never directly ask about. Nobody walks into a showroom requesting a more optimized magnetic architecture. Nobody asks whether software is reducing current losses inside the motor. Nobody compares vehicles based on rotor efficiency, yet those hidden improvements eventually influence everything customers do care about. Range improves, costs. Reliability increases, performance becomes smoother, manufacturing scales faster, the invisible becomes visible through results. And that may explain why Tesla continues attracting so much attention from competitors. Because copying a car design is difficult, but possible. Copying a manufacturing philosophy is much harder. The company isn't simply building products, it's building systems. And systems create advantages that are difficult to replicate overnight. A competitor can launch a new vehicle, a competitor can release a similar battery. But recreating years of engineering decisions, software integration, manufacturing experience, and supply chain optimization is a completely different challenge. That's why the race in electric vehicles is becoming more complex every year. What started as a competition over batteries is turning into a competition over entire ecosystems. Who can build the most efficient supply chain?